And again, thanks everybody for tuning in. We really appreciate it. I know people are getting a little wore out over webinars. Most of us live our jobs almost hourly, taking part in some Zoom meetings. So we really do appreciate you taking time out of the day to watch this live. I'm actually at a remote location that we'll disclose pretty soon, but we wanted to come out and visit a customer. Before we do that, we have some cool stuff to talk about. I wanted to give you just, if you don't know who we are the software data and automation group inside of HP. And if you watched any of the previous presentations that I gave a little bit of a background. I think it's important because most people think of HP either as an industrial printing company or a computer company, or maybe even a 3D printing company. But several years ago, Christoph Schell, who's now our Chief Commercial Officer here at HP, was a president of 3D print and digital manufacturing. And I joined the company back in June of 2019. And when I was there a couple of weeks. I went to a press event where Christoph and the team from 3D Print were introducing a new 5200 series printer. And what was interesting, I hadn't met Christoph yet face to face. We had talked over the phone. But when he introduced himself as the president of 3D Print Digital Manufacturing, he made it a point to tell the media that he said, you know, as much as we're focused on the 3D print industry, he said, we look at ourselves as more of a solution provider for digital manufacturing solutions, and 3D print is one part of that. And so my team, along with all of my other teammates under Ryan Palmer, we were tasked with taking and focusing on areas that the other software companies hadn't really been focused on. So you have traditional MES in addition to ERP and other big systems like that. You have MES, traditional MES from the big companies like SAP, Oracle, and then of course PTC, Dassault, Siemens, and others. And then you have this newer crop of MES solutions that are called additive MES from companies like AMFG, 3Year Mind, Link 3D, Authentize, and others. And that's fantastic, because if the industry is going to grow, we need to have those applications that understand the unique differences between additive manufacturing workflows and more traditional serial manufacturing workflows. But there's still a huge gap that exists. And one of the areas that we're trying to focus on and bring our expertise from the 2D world to bear in the 3D and additive manufacturing world is around high order mix, super high volume workflows. And so in many ways, we're able to partner with all of the DDC members, as well as other companies, ISV software companies out there in the industry, to work together. I like to quote Martin Stoyer, and I know Harshal does as well, because he has really been at the forefront of evangelizing additive manufacturing every event that he goes to. And something that he says consistently, and Martin Stoyer from EOS, by the way, a former Autodesker like myself, is he points out that we all have to work together. In the subtractive world, in the traditional manufacturing world, very rarely do you walk into a shop and see devices or machines from one company. And that's because it's just not realistic to build a business around one particular brand necessarily. And it's true for additive manufacturing as well. You have post-processing devices and all of this. So Martin, when he points out that we all have to work together to bring additive manufacturing to the forefront, he's absolutely right. So we're committed to doing that, and doing that with as many of the DDC members as possible. So shifting gears from that real quick, I want to give you an update on the Universal Build Manager powered by Dyndrite. So as I mentioned, we're focused on applications to fill some of the gaps. And one of those gaps with this high order workflow, this very large volume orders of 1 or 2 workflows, is that we needed an engine that was going to be capable of driving those kinds of volumes. And we did a lot of research into the technologies that existed. And the reality was that Dyndrite, as their kernel, was the perfect solution for us. It gave us the performance that we needed. It gave us the flexibility, universality that we would be able to work with all of these other DDC members, the major OEMs, the SLMs and EOS, Aconity, Ascentium, Aeon 3D. I don't want to leave anybody out, Stratasys, 3D Systems, everyone. we needed to have a universal application. That was number one. It had to be performant. We needed to be able to process tons of orders. We needed to be able to do it in a CAD neutral way. We're trying our best to put STL behind us and work directly with the native CAD files. That was important for us, and that was a nice feature of the Dyndrite kernel. But most importantly for us is, and if you want to know what direction we're heading in, it is the total automation. And so for us, the Dyndrite kernel, by default in the build prep and build management, you are creating Python scripts. So you are capturing the manufacturing intent as you're doing build prep. So for us, it was a great solution to build our application on top of. And so we announced it last fall. Dyndrite also had an event. We gave people an update. We were getting ready to start the beta, but we started working with customers and we started getting a lot of feedback, and we went back to the drawing board, and we are super happy that we did that, because we have really made some tremendous improvements that when we do go to beta in the very near future, that customers are going to be impressed. People are going to be impressed with what they see. So we are planning to do our launch in the fall. Hopefully we'll be able to meet face-to-face at both Rapid and Formnext. And then you guys will be able to see it there. And I didn't want to waste this opportunity giving another demo or having one of our guys, our head of additive, who's in the room with me, Philip Thomas, give a demo, because a lot of people have seen it. You can go back and look at the video. What I wanted to do was I wanted to come to a customer. We're here at Cobra MOTO, and I wanted to actually let somebody that's helping us develop our applications tell you about their business, how they got into additive, and a little bit about what we're doing together, maybe at the very end. So I want to introduce Sean Hilbert, who is the founder of Cobra MOTO and Cobra Aero. So thanks for having us. Yeah, appreciate it very much.
Thank you for coming here.
Cool. His businesses are very, very interesting. And what I want to do before we talk about the business, and I want to run a quick little video, if we could, of Cobra MOTO.
Cobra has an incredible legacy of winning at this level of racing over the past 25 years. In fact, almost every single amateur national championship at Loretta Lynn's has been won on somebody riding a Cobra. It's really an incredible legacy, and to see these kids now as adults that have made their way through the ranks and up into the pros. You know, a good part of the starting line at a supercross race these days is made out of Cobra kids that were our customers at one point in time. And the whole goal behind this motorcycle was to basically make sure that that legacy remains. We've got a brand new bike. It's brand new top to bottom, starting with all new forged wheels that have a new spoke pattern. They're lighter, they're stronger. The suspension is better. The ergonomics and the handling has been improved. Basically everything you need to go win a race, we've made sure that we made better this year.
I think we're good. Are we back? All right, excellent. Yeah, okay, all right, we're good. We're back, thanks. It's a cool video, and it's a longer video if you want to go to their website and check that out. We'll give you the URL later. But before we get started, why don't you tell us a little bit about yourself?
Yeah, so Cobra's a Michigan company. I grew up in Michigan, and a lot of my formative years as a kid, I raced motorcycles, but I also did other things. But I realized that all my friends who had parents in the auto industry, they were struggling. The auto industry was really struggling. The competition was coming in. We didn't know how to manufacture things as well as we should have during those days. The legacy of the Marshall Plan in Japan in particular is really starting to pay dividends. And that gave me a real big interest in manufacturing right off the bat. So I'm an engineer by training, and then worked several years at Ford Motor Company, both in the research labs there as well as in manufacturing. I spent some time on the plant floor, and then I took a break to go back to school. And during that time, I put some business plans together around what the future of a power sport company might look like, because that was my other than manufacturing, that was my core interest.
So you went from Ford to, how did you get to Cobra?
So wrote the business plan as I was at Ford, or my evenings and weekends. Shopped it around, went to the capital markets at the time. It was during the time of the dot-com bubble back in the late '90s, and so finding capital for a manufacturing company was almost impossible, but not impossible.
Right.
We found several groups that were really interested in our ideas. Basically, mass customization in the power sports market, which had really never been done before.
Sure.
And you can see where additive really fits well into that idea. So we gained investment. We actually, instead of a pure startup, we decided that there was a perfect target company that we could go purchase. Sure. They're relatively new. They found some nice white space in the marketplace, in the motorcycle marketplace.
Right.
And so we purchased them 2003, and that's where it started.
So you buy the company, you guys start, was it tough, or did you walk into a pretty healthy business and it just grew? Or
we walked into a great marketplace and a business that was a mess. So we spent several years kind of recombobulating the product, recombobulating our market. But the good news was we had a good tailwind. We had a very healthy marketplace for our customers. The housing market during those early 2000s was strong. A lot of our customer base kind of comes from that.
Right.
Comes from that blue collar world.
Right.
And
now, did you manufacture your own parts back then?
Yeah, so good question. Yes and no. We had a couple of CNCs. We did the bare minimum. We did little round spacers and a couple other parts. But we were like a lot of other manufacturing companies during those days. We purchased stuff mostly from overseas, Southern Europe, Japan, Taiwan. Okay. And we're an assembler. We put stuff together.
Sure. So, so you mentioned the housing market.
Yeah.
2008 comes. What happens?
Everybody knows what happened. 2008.
What happened to you?
Yeah, what happened to us? It didn't happen immediately, but as you might imagine, the economic downturn, discretionary income went sideways for everybody. And buying expensive motorcycles for your kids is not something you do when you don't have any discretionary income.
Sure.
So we struggled. We managed to maintain. We went heavily into export markets. And then we sat down one day and figured, if we're going to keep our guys working, our men and women working, and we're going to maintain the agility that it took to figure out, what the marketplace is going to do, not next year, but next week.
Sure.
I mean, literally, we were week by week. We needed to in-source and home source a large variety of components. So that was really our first major transition as a company.
So you added more CNCs, more fabrication, everything, brought it back in-house.
Yep.
And how did you, so that's more traditional manufacturing, CNC machining, fabrication. Yep. How did you get into additive? What was your start in additive?
Yeah, so like most other companies in those days, additive was, how can we make a prototype a little bit faster, right? So we bought a small FDM machine, MakerBot at the time, made a bunch of little parts, anything that required tactile feedback, right? Anything that was on the motorcycle that would interface with the rider, that we digitally, virtually, we just couldn't tell, is their boot gonna hit that? Does that feel good on your hand? Right. We made those parts, we tested them and very quickly iterated, got a lot of feedback. And boy, it was like a, eye opener. Wow, this really works. It's good stuff.
So did you start to outsource? Did you go to more commercial applications with?
We did. So for prototypes, we pretty much kept stuff in house unless it was too big. Then obviously we had to look for service bureaus that had bigger build volumes and things like that.
Sure. So parts like these, you started to outsource these.
We did. We did.
To Proto Labs.
Proto Labs is a great example. So brokers like Xometry, maybe if Proto Labs, couldn't get us something fast enough. But yeah, we used a lot of different folks.
Did you see? Now I know that you are a very agile company. Your engineering background permeates everything that you guys do here in both businesses. When did you start to make the shift away from just using additive or relying on additive for prototyping and getting into more of the short run stuff, and why? Because I think it's a pretty interesting story.
Yeah. So the first short run thing we did was on the subtractive side. You know,
Okay, yeah.
we built fixtures that could, you know, change quickly in and out.
Right,
Kind of took a page out of Toyota's playbook, built single minute exchange of die. We became students of that whole thing,
right.
quickly interchanging fixtures in and out so that we could do small, short batches subtractively. And that really set our mindset for where we needed to be in the future.
Sure, and you also machine molds for injection molded
Yep.
parts as well, right?
Yep.
Okay.
Yeah.
And now, just out of curiosity, did you bring the injection molding back to the States, or was that still done overseas for the most part?
No, we brought it back to the States during that period of time. So basically one part after another, we created the mold for it here
Okay.
and then local sourced it.
All right, well, we have a couple things we want to show, but why don't you just briefly start off by talking about some of the parts here on the table, and I know there's a story to a number of them, as
There
well
are.
as some bikes that we have over on the
Yeah.
side of the room, yeah.
Yeah, so I mean, the parts that you see on the table here, this basically, except for this old, this is kind of this is one of our very first FDM
FDM parts,
that,
yeah.
that we did. As you can see, this little cutout right here, this is one of those things where, you know, back in 2010, 2011, the value of rapid prototyping was really, you know, that was kind of
Sure,
really coming to the forefront during that period of time. And
Right.
the ability to make that cutout just right was important for us,
yeah,
right?
absolutely.
We basically did a bunch of different iterations, and that was clearance for a rider's boot as they were riding the bike. And we maybe made 10 of those before we hit on just the right shape.
So and now did you do short runs as well with some of these when you were testing, beyond testing them out, when you
Yep.
were trying to go to market?
Absolutely. So
Yeah.
the rest of what you see here are all MJF components built on the 5200 that we have in our facility.
Now, but not back then.
Not back
yeah,
then, right? These are current stuff.
Sure.
And what you see here is basically you know, kind of a smattering of packaging prototypes, you know, looking for fit and finish, looking for tactile feedback. But the other thing you see, and this is a good example right here, is a part that we have really no intention to go into early production with an injection molded part. It's designed to be injection molded.
Right.
You know, it's an open and shut, nice design that would be an inexpensive, relatively inexpensive mold, relatively quick mold to make.
Right,
But for timing purposes, we're going to be running these in MJF for probably the first year of production.
okay, for your new bike. Now, this part is really cool, and you told me a story about it. Why don't you talk about that
Yeah.
and how you use that with that rapid iteration?
Yep. So this is a throttle controller for our new electric products. So we're undergoing not only a digital transformation in how we build our products, but we're undergoing an electrification transformation on a lot of our products, either full electrification in the sense of most of our motorcycle business. We see moving that way. Power plant over the next 10 years. On the aerospace side of things, there's still going to be endurance applications that require engines,
Oh, sure.
but probably hybridized engines, right?
Right,
Engines
yeah.
that drive generators, that drive other things on the aircraft. So this particular component is, you can't just go to the marketplace these days and buy a throttle. You can for an internal combustion engine throttle. You know, there's
Right.
probably 100 of these on the market. But for an electric throttle that requires dual redundant sensors and requires specific technology
Right.
that we're developing.
Yeah.
We need to develop these housings. We need to develop how the sensors mount, how the sensors interact with the
Right.
throttle tube. And that takes a ton of iteration.
Right.
And so
We're
we're able
getting
to do
feedback
that.
from the field, from the racers, from the
Absolutely.
mechanics and stuff like that.
Absolutely. And you know, now by having our own equipment in-house, we're able to not turn that iterative loop into a 1 or 2 week process. It's a 1 or 2 day process.
Sure,
So
sure.
we can really speed the cycle, speed the clock speed, so to speak, of our process.
Right, well, let's do this, because the story actually starts in the metals world, and we'll come to that when we talk about the aero business.
Yeah.
But why don't you take a minute and show the viewers the bikes. We've got a combustion, we've got an electric bike, super cool, and talk about some of the components and how additive allows you to be more agile in business.
Yeah, okay. Yeah. So just a quick overview of what you're looking at. To my side here. These are bikes that haven't hit the market yet. In fact, one of the reasons you see kind of a camouflage on this top unit, this is the first time really the world has ever seen this unit. It's going to be a brand new 2022 model. We're going to launch in September, and we've been utilizing kind of in a very traditional sense, utilizing additive manufacturing to, again, take that clock speed way up of our product development cycle and produce a lot of different iterations on different parts. And just a couple of quick examples. So this is our CX65. Bike on the bottom here is going to be our first entry that's fully electrified. And there's some interesting stories about this bike that we'll go into in a minute. But I'm just going to focus on this panel. We have several MJF components on this bike that we're testing right now. The number plates, what we call the front fork guard, the side panels, even the pan that's underneath the seat is all quickly designed MJF components. And when you have parts that require, from our standpoint, require tactile feedback, and what I mean by tactile feedback is any sort of interface from the rider or even the mechanic. So, what kind of shape does the seat pan need to be so that the rider feels more comfortable? This side panel is a great example. We've got two areas in particular that we did probably, I'm going to guess, at least a half dozen iterations to make sure that we were just perfect. And we can do those iterations, within a 2 or 3 week period, because every day we would receive feedback from the field, do a quick redesign, and then hit the print button and go back at it again. So this hole right here is actually an access port for adjustability for our rear suspension. And it might seem pretty simple. You just put a hole in the side panel, but in reality, that hole has to be lined up just perfectly so that the tool that does the adjustment, can be fed in properly. But the other thing is that the socket is way in there. It's kind of dark, and the user has to be able to see the fastener that they're aiming for. And so just the shape and the size and the angle of that hole took 3 or 4 quick iterations. And in the past, we would have taken a good guess and run with it, and it probably wouldn't have been right. This angle right here, if you can see it, you can see that the stickers are kind of messed up a little bit on the bottom of the panel. And that's because that's where the rider grips the bike. And the shape of this, as their boot grips that bike, we don't want any sharp corners. We don't want the boot to catch anywhere. We want the rider to have a nice smooth transition fore and aft on the motorcycle, because they move around on the bike a lot. And so just the angle of that, we've probably changed 3 or 4 times. And those are the kind of things that we can do to really push the development to a much faster speed than we could otherwise. Again, super traditional, right? Where all of these parts are designed for a higher volume, at least current higher volume production techniques like injection molding, but we're using additive to speed up the clock speed. A little bit different on our new electric motorcycle. That bike is going to go to production in Q1 of 22. It's going to be a 22 model as well, but there's going to be a lot of parts on this bike that end up in MJF to begin with, and that's really to meet launch timing, and we can talk about that in a minute.
Yeah, sure.
But there's a big in this side of the business, on the motor side of the business, launch timing is everything, as you can imagine. New model years come out, and if you don't hit that, then you basically lose all that time in production until the next model year comes around. So if we lose a month, it's not just being a month late. We've lost that production window.
Whole season.
We could lose the whole season if we're not careful. So anyway, that's a quick overview. Really fun new products that we have coming out, and additive has been a key part of the development process. I'll even show you. This is the battery pack down here. We had enough build volume, just barely, within our Renishaw AM400 to print the entire battery housing at one point. That's a cast part eventually, but we were able to really get there much quicker by using our additive capabilities.
Very cool. Yeah, and so this is an MJF build of just the housing, because you also were testing some of these component parts as well, and you even said that some of these these are not just prototypes, you're going to go into production with these as well.
Absolutely. So, you've got things like battery covers, bezels, more covers up here. Internally to the battery, you can't even see it, but the array that actually holds all the cells in place while they're being actually right after they're welded.
Okay.
Those are all going to be additive parts, and I don't foresee. I guess here's what the future looks like. We, as you mentioned earlier, we make all of our injection molds in house. We've got one mold maker. We're a small company. We're under 50 people. So we have one mold maker that's going to make this mold, and then he'll make this mold, and then he'll make this mold, and then he'll make that mold. And so I mentioned how important launch timing is.
Yeah.
Well, we don't have to wait for him to finish every mold anymore. We can literally get to production when we say we're going to get to production, and prioritize what I would call cost reductions or cost thrifting over time.
Right.
Yeah, okay, this part in the long run probably should be an injection molded part, at least in the next foreseeable future, right? Maybe in 10 years, we wouldn't even think about building a mold for this part, but now we will. It's a few pennies to make in an injection mold process, but we're never going to let that delay our launch timing ever again.
Right, so you mentioned the metals, and so what I want to do is I want to shift gears and talk about your other business called Cobra Aero. And before we do that, let's run another quick little video to give the viewers an idea about that business. All right, we're back. Thank you. We did a quick change during the video, and we've got some parts up here from Cobra Aero. And so let's see, we talked about you really got into commercial additive with metals first. So we need to go all the way back. So you have Cobra MOTO.
Yep.
And you deal with that lean transformation 1.0.
Yep.
And then how did you get into the aerospace business?
By brute force and awkwardness, maybe. I don't know. We came to the realization at one point that in the middle of the economic downturn, that was probably about 2010, 2011 for us. Things got delayed a little bit, in terms of when our market really hit rock bottom. But we came to the conclusion pretty quickly that we needed to look for adjacent marketplaces that could utilize the great folks we had, the great equipment we had. Basically, were there any core technologies that we were really, really good at that other markets needed?
So did you just came up with this idea, or did you have somebody approach you with a problem, or how did it work?
Yeah. So the first I thought about doing small engines for drone aircraft, and keep in mind, right about that time we were what, almost a decade, maybe a little over a decade into the conflicts, in Afghanistan and Iraq, and you're just starting to hear about these things called UAVs on the news, drone aircraft, some people are calling them. And the reality is that from about 2002 on, our soldiers were using really small aircraft in the Middle East to basically be eyes in the sky for them. To look over the next you know,
Hill,
three
yeah.
streets over in Fallujah or the
Yeah,
next
sure.
hill or whatever.
Right.
They're looking for, they're just trying to be safe, right?
Right.
Trying to protect themselves. And the problem is that these aircraft got rushed into that use case so quickly
Right.
that I visited a company in Hood River, Oregon called In Situ. They were kind of the first big players on the UAS market. And I met a general there that was there for a visit, and he said, you know, I've got a $250,000 camera
Right.
on one end of the aircraft, and I've got a piece of junk hobby engine that I can buy at the local hobby store
Right,
on the
sure.
other end, and I'm
Yeah.
losing $1 million
Oh,
in
wow,
cameras every month.
Yeah.
I need a better engine. And so that was like, you know, that was it. That was the spark that
Very
really got
cool.
us going.
So when you started out, did you start with additive from the very beginning with that business, or what?
We didn't, you know, we
Okay.
really started with, we started, I would call it additive light. You know,
Okay.
we were, a lot of our prototyping, especially for engine components, were cast.
Okay.
They were rapid casts, so they used,
Right.
you know, they used some additives in
They were
the
printed,
process.
yeah.
Yeah, the cores and
Mhm.
things like that were printed. Yeah.
Okay, awesome. And I've noticed this, and I'll tell you, the video is not going to do this justice. It is a work of art, and a lot of the components on here. So, and we can't zoom in, but I do want you to talk about some of the pieces on here.
Yeah.
The cowling, some of these pieces now for mounts, engine mounts to the fuselage, and this is a pusher. So it's in the back of the drone, the back of the
Right.
UAV
Right.
or SUAV,
Yep.
and it pushes the plane.
Mhm.
But you have these incredible mounts. These are titanium printed on a Renishaw printer, which is your very first printer, right?
It is.
And-
Renishaw AM400.
Now, were these generatively designed at all, or were they just sort of, do you guys do it yourself, like
We
manually?
did a little bit of
Right.
kind of pre-generative, but more topologically optimized stuff. You know,
Okay.
it wasn't, I wouldn't call it a pure generative design, but it's certainly optimized.
Okay, sure. But so tell us a story. How did you get into the Renishaw printer?
So we knew kind of early on that we had a couple of choices in front of us. We could tool up for parts
Right.
like this, which severely limited our flexibility, right? As you well know, that's a beautiful part about additive.
Mhm.
And it also took a tremendous amount of time to get where we
Right.
needed to be. And I had a conversation with one of our customers one day, and he's like, you know, if you were to build an engine frame, wouldn't it be really cool to integrate, you know, these three parts? And if you did it additively, you could do that. I'm like, wow, that's really cool. So
Yeah.
immediately we started conversations. Went to Chicago, visited the folks at Renishaw. They were awesome. Really helped out a lot in terms of strategically what direction should we go forward.
Sure.
Should we rely on service bureaus? Should we pull capacity in-house? And it took us about a short 3 or 4 months to make the decision that, you know what, we're going to dive in. We're going to dive in and make you know, this digital transformation, really.
Sure,
I mean,
yeah.
that we needed to make to move us to the next level.
So almost from the very beginning, you started to move and think about designing the parts specifically for additive.
And, yeah, and this mount is a great example. So we have 3 competitors' mounts in back. This whole mount weighs just over 100 grams.
Yeah, it's featherweight.
The lightest competitor mount out there for this class of engine is about 380 grams. And if it weren't for, and not only that, we've integrated several parts into the mount itself.
Right.
So it's not just a mount, it's a mount, it's a servo mount here. It does a lot of things that you know,
The traditional mounts don't do.
Exactly.
And not only that, it's either you put more fuel in the UAV, or you have to shorten your mission time, because you can't be in there as long, obviously. So this extends mission time and or lightens the weight, and just saves the fuel and improves speed and things like that. Yeah, talk about that part. It's so really cool.
This is the cowl. So this actually, you know, cools the engine. The engines at this point in time anyway are air cooled. We've got some incredibly cool designs that we're working on right now that are liquid cooled as well. But this is a great example of a part, and that's a key distinction really between the aero business and the moto business.
Right.
I mentioned before, everything we're designing is around the capability to be injection molded, right? We want to make an open shut mold, maybe a cam here and there to get rid of a locked in part, but really everything is with, we're gonna
Ultimately, you're gonna go
higher
to traditional
margin. Yeah.
manufacturing, yeah.
just the opposite for aero.
Okay.
We realize it's a different marketplace, different margins. So costs can be a little bit higher. So we dove in right off the bat with design for additive.
High margin, high value parts.
High margin, high value. So what can we do with additive from the design standpoint you could never, ever do with any other manufacturing technology?
Sure.
And if you pretty much everything you look at on this engine that's additive, that includes the exhaust system, the cowling, the engine cylinder, the cylinder head, the mount, the intake manifold, a lot of the linkage systems that are controlling all this stuff. I mean, about 60% of this engine is additively manufactured. And every single part that is additive is designed to be forever additive.
To leverage the benefits of additive as well. Not only in part component count production or count, but also in the actual performance of the part as well. Now, there's a part, and I know they can't see it. I'm going to try and move this around. It's always dangerous during a live event. And I know we can't zoom, but this exhaust component here is absolutely amazing. And I know you have, is there a story here? Is that like an older traditional design and an updated?
Yep. So this is our subtractively bolted together machined part. It's got 13 different components. It's, you know, as you can tell, it's very friendly for subtractive manufacturing, right? A lot of right angles, a lot of, you know,
2.5 axis.
2.5 axis stuff that's going on. It's heavy. It weighs about 150 grams more than the additive part. And as you can see, the additive part, we've kind of, this is angled. I don't know if you can see it on the screen or not, but this part is angled into the nose cone or the spinner, we call it, on the aircraft, and that helps the airplane cowl better, so it's more aerodynamic.
Right.
And it also helps the propeller be more efficient because you're masking less to the prop. So
and even the airflow is matched to the radius of the spinner as well.
Yeah,
so.
exactly. So, you know, huge improvements designing for additive manufacturing. And that's not where this ends. Where we're going is we've got a contract with Air Force Research right now. And the name of our what's called an STTR is using additively manufactured novel shapes to help attenuate sound. So we're this outlet right here, what goes inside of the muffler is actually going to be the only way you could ever make it would be additively manufactured. It's probably going to be, it's going to, you know, use lattice structures and things like that are very complicated, but they follow the additive paradox, right? And that is sometimes the more complicated a part is, the easier it is to print. And so things that you could never do subtractively or any other way for that matter, we're going to be doing on this aircraft engine within a few years.
Sure. And, you know, for full disclosure, we were originally contacted for your metal printer. We had someone that saw the announcement and a former Renishaller, we'll say, and they reached out and you were interested in doing some testing as well for the application. And we were obviously looking for people to help us, and then found out that you guys were in the midst of considering purchasing an MJF printer to go along with the Renishaw printer, an HP printer, 5200 series printer, to bring that in-house. And I remember talking to you about it because we were interested in working with somebody that had multiple machines from multiple manufacturers, multiple processes, especially around metals. You know, HP is doing some metal stuff, but they're, you know, not as far along as the other guys. Obviously, the big ones, SLM, EOS, X1, et cetera. Renishaw has been around forever in the business. And so we were eager to work with you and your team to figure out, because it's one thing having an idea about solving these problems. And even though we're going after traditionally a different type of business for the larger application, the engine has to be robust enough to be able to deal with all of these parts and all the different materials. So we started working together before you even got your HP printer.
Right.
And so today we're working with you, and you're using the Renishaw QuantAM software as well. To do some of the tool pathing and things like that while we're doing our testing and evolution on things. So that's been great for us, and our team's working with your guys on that, because again, at the end of the day, even though traditionally, we would go focus on like the really high-end, high value, very sophisticated, very large parts. Some of the manufacturers, OEMs, they have build volumes that are a meter in size, right? Which is larger than both of your machines.
Right.
And so the amount of data that we're dealing with, it just increases astronomically. And that's something that Harshal talks about. He's been talking about it for years, and we're getting to that point right now. And so I know that that's the more and more sophisticated parts you guys are designing, the lightweighting, especially some of the insides of some of your engine components, means there's a ton of surfaces, lots of voxels that we have to be able to process, and you need to be able to do it very quickly. And in your case, it's because a race is coming up. We're talking about you have a race in the weekend, and you want to come up with, I don't have it anymore, but that throttle body assembly. Well, you want to have 3 designs, and you want them all tested out, and you want to get feedback, or you have that side panel, and a mechanic requests it, you send it out. Is this what you're looking for? Is this going to work? You have to be able to process those builds very quickly for both metals and plastics as well.
Yeah.
One of the things
And
that
I call that, creating at the speed of thought, right?
Right,
When we think of something with modern CAD tools, you can create the digital design very quickly,
right,
but then being able to actually create the physical part almost as quickly or quicker even.
right.
That whole process, compressing that timeline is incredibly important.
Sure. And so for our relationship, it's more about pressure testing the engine for our solution and making sure that it's robust enough because typically we go after the customized, personalized, on-demand, known part, even though there's modifications to it, there's texturing, there's labeling, things like that. It's not quite like the service bureau type of an application where they may get an order for 10 of these mounts in the morning, and they've got an order for 25 of these, by the afternoon. So it's really interesting. And of course, one of the things that we've talked about too is that there's product development, process development, and production. And our emphasis is focusing on a certain type of production business model. When we talked about this, and you mentioned when we made our announcement, a lot of people ask, because we have a lot of partnerships with Siemens and Autodesk, Materialize, and one of the questions was, and of course now Link 3D and AMFG in the additive MES space, and people are like, well, what are you guys doing? And it's like, well, we didn't set out to compete head to head with those guys. We didn't set out to create a category killer with our engine. We set out to create a new category altogether. But again, at the end of the day, it has to be robust enough to deal with all these real world parts. It's even though we've sort of we've picked a really interesting business and market segment to go after. The reality is that even those other MES systems are going to need a tool if they start getting into higher volumes of production to be able to support parts like this. You mentioned that one of the big differences between Moto and Aero was the fact that you're designing your parts to be thrifted or for eventually to go to full scale production with traditional injection molding and CNC machining and stuff like that.
For now.
For now, right? Yeah. Exactly. Well, of course, the cost are always going to come down with additives, so it is going to be interesting to see where that transition starts to happen, if it starts to happen too. So one of the things that you talked about was how your business has evolved, and you call it, I mentioned the lean transition or lean transformation 1.0. You started to go into the lean transition or transformation 2.0 when you got your first, what I call commercial industrial 3D printer, which is the Renishaw.
Right.
Should be pointing to metal parts here. The Renishaw printer. How do you see your the next steps for these businesses evolving using additive?
Yeah, so lean transition 1.0 still required that we had a deep supply base, and we still have 150. We have 150 global suppliers. We've got one purchasing and logistics person.
Right.
And that's an incredible amount of complexity in a supply chain to handle with a very small staff. And so we're always looking for a way, how can we de-risk the supply chain? How can we bring things closer to home? How can we have, as I've been saying for a decade, how the heck can we control our own destiny in more than one way? And I can give you story after story about parts that were, left on a boat and ended up going around the.
Wait, hold on. You had a container that was stuck on the Evergreen ship in the Suez Canal. Was that?
We still haven't got, we saw the manifest.
Oh,
and
okay.
It looks like it's there. We still don't have the parts, and we don't know yet. That's the perfect example of a supply chain risk for us, right?
Yeah.
So
That was funny.
that a more very real world, closer to home thing that we have going on right now is our castings.
Yeah.
So we've got a local casting company that is 21 weeks, lead time, which was 8 weeks a couple weeks ago. And that's the,
sure.
When you look at our MRP system and it says 8 weeks lead time and everything's driven off that MRP, and you send the PO and then they say, oh, no, you're gonna have to wait till September now.
Right.
Those kind of disruptions just blow our business to pieces. So we have to figure out ways to bring things closer to home.
Sure.
And luckily for the aerospace side of things, we can go literally 1 4-inch wall away from our lunchroom and make more, castings.
Right. No, exactly.
It's crazy
Yeah.
to think
That's
how
awesome.
clean and how lean that is, but that's what we're doing.
Yeah, it's impressive. And your operation, I know we didn't have time, and logistically, hopefully we'll be able to do a video to do you guys more justice as far as the production end of things. But it's very impressive to see how quickly, even on the plastic side, you're able to stand that part of the business up. And I mentioned that for us, when working with you and with Renishaw, with the Quantum software, our key focus for the UBM right now is number one, compatibility. We know all the features that we need to be able to support for the types of applications that we're going after. But we need to make sure that, first of all, we're compatible with all these different devices that are out there. And again, I would really appreciate all the help and feedback that you're able to provide, and validation that you're able to provide, and working with some other people as well with some different types of processes. But interoperability is the next step, and that is working more closely with some of the applications from folks out there that are used to specifically drive their particular machine types. And that was one of the other aspects that we were, when we selected Dyndrite as the core technology inside of our UBM, Universal Build Manager, it was because of this plugin architecture that we have. And so we're working with a lot of people right now because the IP, the secret sauce from all these OEMs, they're certainly not going to give it to HP, and they don't want to give it to anyone else either. And so for us, having this plugin architecture allows them to not have the risk of exposing their IP or losing any control over their IP, but still at the same time, we're able to have a more seamless integration with their devices, and it's one interface, which is great. And that's what everybody's looking for. And it's not entirely new, but it's certainly one of the key pillars, if you will, of our application. We know we need to be able to do that. And we don't want somebody to have to go out of one application to go into another to do it. This is something you guys have talked about as well. It's like, it's a hassle and it's a waste of time. And when you're training new employees, this is another thing around the automation. And this is what I wanted to sort of end our little discussion about, was on this focus of automation. There's 2 levels of automation. There's the factory industrial automation, like robotics and making your operations more efficient.
Yep.
But then there's the software automation side of things. So why don't you talk a little bit about that?
Yeah, no, and that's really important for us going forward, right? Our best and brightest right now are spending a lot of time, putting builds together, right? Making sure that things are oriented just right, making sure that we've got, parameters set properly, making sure that if we need to on the metal side, that things are supported the way they need to be supported. Lots of kind of just grunt mental capital is going into each build.
Sure.
And the more that we can streamline that process, and the more that, the 2 things that we really look forward to are automation around orientation and automation around serialization.
Oh, and traceability. Yes,
and
for
traceability. Traceability is huge.
Super
we want to know, we want there to be a number on this part. We want to know where in the build chamber it was built. We want to we want to store the metadata around laser parameters and things like that. Maybe some feedback, temperatures and things like that.
Sure.
But we want to be able to have all that information at our disposal down the road for full traceability. And not only that.
And it has to be automatic. You
It has to be
can't
automatic.
risk getting the wrong serial number, the
Yep.
wrong number on a part. It's,
Yep. You mentioned
can't do
lean 2.0, maybe lean 3.0 is us determining what set of parts we need 3 days from now.
sure, yeah,
And pulling that, a pure lean pull system, pulling those 28 different parts together, kind
Right.
of like a service bureau would do,
Yeah.
except we need to have serialization, we need to have full traceability, and we need to know exactly the orientation this thing is going to be built in every time,
right,
so that we have the material properties and the structural properties that we think we are designing into the part.
exactly.
And we can't have a human being doing that every single time.
Exactly. So it's not only the knowledge about how you're manufacturing the parts, it's also making sure that you are de-risking the manufacturing process as well, because again, in aerospace, you can't afford to make one mistake. It's you just can't do it. So what I want to do is, I know we're at almost at the top of the hour. And I know folks are getting ready to go to lunch out there, so it might get a little bit noisy. Might be a perfect time to switch over to the Q&A session.
Sure.
Before I do that, thank you so much for having us out here.
Yeah, thank you.
The products are amazing. They're awesome. And the website for Cobra Moto, what is that?
So just cobramoto.com, easy to find, and then Cobra Aero is cobra-aero.com.
Gotcha, awesome.